Okay, so welcome to another Microservices meetup. Glad that so many of you showed up. I was a little bit nervous today because being speaker myself, this is not as easy as usual. Usually I just introduce and then hand over to the speaker. Today I can't do that. Who's here for the first time at a microservice meetup? Okay, still a lot of new people. Welcome to our meetup. Please come back and enjoy the socializing, the pizza, beer, and the talk, hopefully. Without further ado, today we are introducing Highway to Heaven. We announced it as from stop and go to Autobahn, but we changed the title midways. With me today is Schlegel from Thoughtworks, coding architect.
And we have Deger from Autoscout, also coding architect.
What a coincidence.
So we are pairing while coding and architecting.
Yes. And we also got a hidden agenda today. The hidden part of the agenda is that Thoughtworks and Autoscout is hiring. Besides that, we won't talk about it anymore. And we also have a real agenda. First of all, we're going to meet Autoscout 24.
And then we look up what's currently happening at Autoscout. So for now, we just announced it's something about shifting gears.
Yes, and then we will tell you a few stories how we build our services. So we don't have the truth of microservices yet. We are just telling stories of our journey along the way, what we learned so far.
And then we look at the actually difficult part, because building stuff is easy, it's all technology, what could go wrong? But we're looking at how do we organize ourselves, so kind of what are the people things we are encountering on our journey.
So what's Autoscout from 10,000 feet? This is not everything Autoscout encompasses. This is what I feel is important from Autoscout. So we have dealer stock management and private seller. Those are those areas where dealers that want to sell their vehicles are able to manage their stock. And the same goes for private sellers who want to also sell their vehicle. And from those contexts, classifieds could be published, which then would end up in the classified service. On the side, we have something like ad sales, which I won't go into, but it's, as you know, many websites feel ads contribute to their income, so this is welcome. On the top, we have analytics. Analytics is also interested in classifieds and also in all the changes and things that happen in the other parts of the application. And then on the right-hand side, we have what we call the public web or the search funnel, where we have the search and the details, and we have one example in there of a service that's also interested in classifieds. This we call the watches. So when you're on some page at Autoscout where a classified is displayed, you can put it on your watch list. And there are a lot of parts from Autoscout that are missing, but this is from an architectural standpoint the interesting parts. The other stuff is comparable to what other companies have. And what's interesting is, to me, that those things on the left-hand side, publishers classifieds, which are then searchable and displayable on the right-hand side. An analogy that I find interesting is how previously classified listings were handled. When you would like to sell your car, you would go to one of those printed papers, Süddeutsche or something like that. You fill out a form, go there, pay money, and after a few days of processing in-house, verifying that this is not a fraud, that actually the money was paid. This would be the left-hand side of the journey of this vehicle to be sold. And this is the back-end processing, and at some point in time, this classified will be published. And this is then the right-hand side of Autoscout. And the publishing part is almost completely different from the origination part of the classified. then it's not longer interesting. There are not so many business rules involved and stuff like that. It's more about getting lots of printed paper with a nice layout out of the door for people to be able to search. And this differentiation also plays within AutoScout. So there are the complex rules of how to pay stuff and how to organize your stock. And on the right-hand side, it's more about scaling and mostly about searching, finding, displaying stuff that's mostly read access to those classifieds. So classifieds go from the left to the right. Where does AutoScout currently stand? Or did stand half a year ago, but main core parts of AutoScout are still there. So we have a highly optimized IT platform, which is based on the last decade, meaning this is from the PC web area, this is from the data center area. This is run efficiently, it's cost optimized, but it's not what we would consider 21st century. But this platform supported our growth for more than 6 years, so it's proven it worked. And it's a Microsoft-oriented stack, which we'll come to later. Microsoft implies .NET Windows stuff, and which was 6 years ago maybe a good idea, today maybe not. And the whole thing is also more an enterprise IT setup. It's not a web company setup. So when you look at a web company today, you see lots of cheap hardware running and with resilience, and servers are allowed to die and will just be replaced by a new instead of a virtualized thing. And this is from the area where you have hardened servers, redundant power supplies. The stuff we are operating currently is optimized for mean time between failure and not for mean time to recovery, so no resilience or stuff like that. And the processes we worked with have proven to be successful, agile and lean principles. So this is the baseline where we started from. And in about early 2014, that point in time, let's start. We had the monoliths. So there's no microservice story without a monolith at the beginning. And because we wanted to increase our delivery throughput, we split up into smaller swim lanes, which were still coupled by the database, but it allowed us to advance in continuous delivery. And then in early 2014, we thought about how we could evolve those architecture principles. And after some workshops, we finally realized our next step, what we have put up on the whiteboard, is more or less exactly what the definition of microservices was. So we decided this is the way we want to go. And when we are talking about microservices at AutoScout, this is an important differentiation for me. We are not talking about microservices in the Netflix style. So a lot of small microservices, 300, 400, and an API gateway on top of it, and then lots of channels supported by it. I would call it, we are doing the Stefan Tilkoff style of microservices. So our microservices are more or less vertical slices, which encompass their own UI, and are in the current state not as small as they might end up. We might cut them into smaller pieces later on, but currently I would call our microservices rather fat microservices, but still obeying all the rules, I would say, like microservices. So, after we decided microservices are the way to go, something happened. You might know that AutoScout, not only AutoScout, Scout24 was sold, and we became a new CEO, Greg Ellis, and he had a lot of interesting questions for us. And the question, are you ready for the future? Is this the right setup for the 21st century, what you are doing there? And he also worried a little bit, or rather strongly, about the .NET Windows stuff. He came from a Linux background and was worried because he didn't like Microsoft, so he asked a lot of questions. Is this funny? Do you feel the pain? Okay. And the most important question he asked was, do you attract talents? Is the stuff you're doing, is this the right thing to attract the talents that are out there? And then we reflected on that and found out, yes, we get good .NET developers. And they know their skills, they know Agile, but few of them actually were good at what we could call, have good web experience. In Munich there is banks and insurance companies, and so a lot of the enterprise is a place where .NET is rather strong, so you get a lot of .NET developers that are good developers, but with those backgrounds. So we had to teach them how to work in a web platform environment, and this was a pain for us, and we felt it. And then we questioned ourselves, why is this? What's the problem with .NET? And then we thought about a flywheel. A flywheel that's going from a good technology that sparks excitement, has a community around it, and then attracts talent, which builds even more exciting technology in a community, and the flywheel spins. And in .NET, this flywheel exists. There is good open source software as a community in .NET, but when you compare this flywheel to what happens in the JVM Linux environment, this is a way bigger flywheel running there, and it's running faster. So this made it clear for us that we need to change something. And at that point in time,
enter Project Tatsu. So the change. So Tatsu is Japanese and stands for Flying Beast. It's a dragon. And the video we have seen before, while we were eating pizza and drinking beer, was actually from a roller coaster, which is named Tatsu. And at times what we are doing feels like riding a roller coaster. So hence I think it's a very, very fitting name. And let's move on and let's see what makes up the roller coaster. What's the thing we are doing. So, as Christian described, coming from data center, coming from .NET, coming from development teams sitting over there, operations over there, and so forth, AutoScout identified 5 things they wanted to change. And one is, well, let's get rid of the monolith, let's start using microservices. Let's move away from a data center and move into the cloud, and in particular, use AWS as a cloud. And we already mentioned, let's move away from a .NET platform and instead use JVM on Linux. And then on the people side, we have aspects like, let's start bringing in a DevOps culture into the team. And DevOps is nice because it fits nicely onto this slide. There's always a risk that people don't understand or have different definitions of DevOps. So what we mean by DevOps is you build it, you run it. So teams own services, and they are not only developing these services, but they're also operating these services. And the team members come from different backgrounds. So there are some people kind of devs or former devs, such as myself, and we've got people coming from operations, and we get together as a team, and we are responsible for getting the server developed and run it. And we're going to see a few implications of that in the course of this presentation. And the last one, but by no means the least, is think in terms of products and not in projects. So we had the last project on the previous slide, which is Project Tatsu. As of now, it's only products. It's a different viewpoint when you say, well, we need to find a new product, or what do clients like about our product, and what is the competition, what products are they launching. Very different way of thinking, which fosters innovation. And then we ask ourselves, well, how do we achieve this? I mean, we've got 5 changes, all at the same time. So can we sit back and migrate everything? to the new platform, and tell the clients, well, just hold your breath. We're not actually innovating for a year or two, but if you come back, it's going to be all brand new, and then we start innovating again. Or do we throw away everything and start from scratch, say that this is a green field, and we completely define new products? And what we came up with is what we call the shiny new cut. So it's trying to combine the best of all worlds. So what we want to do is cut to the core. So identify the relevant parts, which we want to migrate to the new platform. And by the same token, identify the parts you want to leave out, you do not want to migrate. Then add new business value. And this means we are kind of thinking of new products which we can build while we are migrating the core to the new platform. And this is interleaved, and we're going to see examples of both in the session. And let's try a new user experience. So if you look at what we internally call the PC web, it's a very traditional web application. And there's a mobile web, which you can see on the mobile devices, looks very different. And this is kind of the way we are going. And you've got this kind of these icons down there, which kind of represent, you've got the core in the middle, you build new stuff, which is gray, but still can be polished a bit. And it's all shiny, so we've got these. This is the idea. So try to combine these things while achieving these 5 migrations. And kind of some more objectives on top of that, more from a business viewpoint. So we want to do mobile first, and the application should be user-centric, user experience should be great, less time to market. As Christian already mentioned, it's very important to attract talents, get people on board, and we always want to reduce costs in IT production. So this is kind of a picture that kind of shows the idea of how do we translate the stuff. So we have seen before on previous slide the monolith and the kind of the 4 tiny monoliths and then all the microservices. But what does it mean in practice? So here we see on the left-hand side the monoliths and its kind of smaller siblings. And if you look at the transition from number 1 to number 2, we want to cut out a vertical slice and translate it in one-to-many microservices. And the important thing here is it is a vertical slice, so it also contains the UI. So we had quite intense debates about that. How do we, what do microservices do, and where does their responsibility end? And there's one school of thinking that says, well, you've got these microservices, they give you APIs, and then you've got plenty of them, so you've got plenty APIs, and then you put some UI layer on top of it, which is kind of lying horizontally across all the services. And the other school of thinking is, well, let the services be independent. So each service should serve or provide its own UI. It should be self-contained. And this is the model we are approaching. And when implementing this, the discussions behind these are kind of, the first model, people say, this is highly optimized. It's very easy to tweak the JavaScript and the CSS, and we can be super, super fast. But the price you tend to pay is dependencies between different domains or bounded contexts. And then in order to change one thing, you may need to talk to 3 teams, as opposed if a microservice is truly self-contained and provides its own user interface, time to market is much easier to achieve. And we decided to give it a try. And right now, one of the experiments we are doing is we are learning how to use UI composition and using edge-side includes on the cloud. And then if you look at it from 2 to 3, we take the next thing out of the cache stack, which is the existing platform, and create ever more microservices. And one thing we learned on this journey is that if you take out one slice, you realize, I need something else. And if you recall the very first slide where Christian explained, this is what AutoScout are doing. One way of looking at this slide is these are all bounded contexts. And so when putting out stuff, it's very important to realize when you meet a new bounded context. And don't start to, by accident, to implement 2 bounded contexts within one service. An example for that is, we started building the watch list, because it's a fairly easy feature. we were learning many things about the platforms as such. And at some point we said, well, in the watch list, actually we want to show things about the classified, the picture, and kind of what make is it, and what model is it. And so the watch list team started a new independent service, which is the classified service. And this is an example of kind of how to separate bounded contexts, and quite important, because otherwise you may have microservices, but they may be very messy. And so we like to compare what we're doing to these people over there. But hang on, what they are doing is pretty easy. Because they've got a pit stop. So race car comes in, and guess what? It actually stops. So they can change the wheels and refuel and kind of polish the body a bit, if you like. We need to change the wheels while driving. So we cannot stop. So we have to find ways to reconcile and to kind of keep coexisting and to integrate the old world, which is the cash stack, which is keeping the lights on and earning the money, and the new stuff. And we're also going to see more about this later, how we try to achieve this.
Okay. You need to have some principles how you would like to do this. This was not our first draft, this is our current state, what we are doing. And what you are seeing on the left-hand side, these are our strategic goals. This is what we want to do. We want to do the main reason we are doing this is to actually reduce time to market. Doing microservices, going to AWS, all this increases the cycle time of experimentations, so the build, measure, learn cycle is then increased. The next thing that is important for us as a strategic goal is support data-driven decisions. So to actually start a new platform with the things in mind, to not throw away data and to have everything available to enable those decisions. And which could be a subpart of data-driven decisions is the cost transparency, but as we are going to AWS, cost transparency is one of the main selling points of AWS compared to a data center where you're not able to tell what each of those services, what each of those business capability actually costs, and make decisions about values and costs and stuff like that. So we put this as a separate strategic goal in there. And to support those strategic goals, we have many architectural principles and design and delivery principles. And we did this poster in order also to support decision making. If in doubt, when a team discusses, we want to do it that way, we want to do it that way, turn around, there's a poster on the wall, and then look up. Does this align with our principle, or does the other part align with our principles? So that while giving the teams autonomy, they still have guidance and principles at hand. And also, as we are doing things while we are driving, and we don't have a pit stop, as Wolf explained, we have a constant ramp up of new people joining. And going back, I believe I've been thinking about Tatsu now for almost a year, and now new people are joining the teams which are new to those concepts. So those stories we explain to you right now, we explain to them, and to help them to align with the ideas behind Tatsu, we built this poster. And I will go into some of those principles in more detail. If you want to do something for yourself, don't copy our principles, please. So you can use them as a guideline, but think about what's important for you. So, as we are not Netflix, which we are in the first iteration we believed, we copy everything from Netflix, but we are not delivering videos. So are you probably not in the classified listings business, so you need your own principles.
Yeah, there's reasoning, hopefully, behind the principles, and we had debates and discussions, what we do this, over that. And what we find is when spinning up new teams, people come along and say, oh, hang on, this principle, surely it's wrong. Because I've done it different for all of my life. And so I can I can sympathize with that because some parts I have done different in the past, so I can understand that. And then there are kind of debates and discussions, why are we doing this? So just copying it would be very risky. Yes. You'd be missing out the important part, which is the discussion and understanding what is it really about, what is behind those principles.
So we picked a few of them because the other one was overwhelming. One Wolf already mentioned. We try to organize our services and our teams around business capabilities. So foremost, we want to organize our teams around business capabilities and then try to make the inverse conveying maneuver to actually hope that the architecture that results from that also aligns to the business capabilities. The ideas behind that is rather simple. Open the blue book, chapter 10 onwards. If you have not read it, please do it. Eric Evans has done a great job explaining bounded contexts and the ideas behind it. And as Wolf already mentioned, when doing microservices, getting the context right is more important than when doing a monolith. Because in a monolith, you have more tooling, you can easily refactor and move models around if you don't get it right. With microservices, if you don't get it right, you have either chatty communication between those services, and you have a lot of cross-team communication, which is violating one of our other principles, having autonomous teams. So this is important to us. Also very important to us is you build it, you run it. As Wolf already mentioned, we had a legacy of strict separation of dev and ops, and we evolved this and had more DevOps in a different definition of DevOps, and now we believe that a team that builds a service afterwards should be responsible to actually maintain and run the service. So people own a pager, they respond to failures, and also the team is not only running it, but it's also improving it, so it should listen to feedback of their customer. They should be close to the feedback that's coming from the outside. So this is what we believe will solve the problem of the handover. This is the pain we felt. Somebody is developing it, another team is operating it, it breaks in production. The one who developed it is in holidays, and the one who didn't develop it has to maintain it, has to keep it running. This is not fair. The feedback of the broken application should go back to the guys who wrote the code that failed. So this feedback cycle, I believe, is an important thing. If you want to sleep on weekends, you should build software that doesn't fail on weekends. And nevertheless, we also try to be bold. And what we mean by bold is not be stupid, but, for example, don't over-test stuff when a service is not in production. You can build a service and have a test suite this large, every edge case you have thought about, and experience tells us if you put this into production, stuff will happen you haven't thought about it. And then perhaps the APIs, the design, the scaling, something is wrong. So strive to put stuff in production as early as possible and then continue to learn on that. And this also includes, you need to be able to think about recovery. If you're bold, you also need to be able, if something goes wrong, and the bolder you are, the likelier something goes wrong, you need to be able to recover from that. This also goes back to the thing we mentioned previously. Don't optimize for mean time between failure, so don't try to build something that does not fail. Build something that recovers fast, or that is resilient, that if it fails automatically starts up a new instance or switches over to something else that's working, and don't try to build a infrastructure that if it fails you can't recover, but you hope it will not fail and build everything to not make it fail. The fourth thing that's very important to us is a clear separation between macro and micro architecture. So when talking about microservices, we're talking about the the small pieces and all the advantages it gives us. It fits in my head and I can rebuild it. I don't have to refactor anything in there. If a new team takes over the service and it doesn't like it, you can build a new one. All this thing within the microservice needs a macro architecture surrounding it. And for us, the macro architecture is the stuff that's not up to the discretion of the team or the microservice, because it's a concern, it's a macro concern. This is the stuff that shouldn't change, and all teams must adhere to it. For example, in our case, we say you need to use this logging infrastructure because if something goes wrong, and we need to correlate what service had behaved and how things went wrong, we need to have a central place where you can look up the logs. So this is not up to the discretion of the otherwise autonomous teams and their microservices to store the logs where they like. They must adhere to the convention of the macro architecture. And there are a few things that are in this area. For example, security, data formats that are exchanged between services, logging, and other things. But it should be as few as possible, and the rest should be up to the services to decide. And this allows to keep to build microservices that are well behaved within the macro architecture, so that there are good citizens in there. And the last thing I want to mention is event sourcing and event publishing. When thinking about how to integrate microservices, there are different ways you can do it. And one thing that helps you is when you have events that are published from one microservice be consumed from another microservice. And not, so I personally don't like chatty microservices, so that if a request comes in, it talks to 5 other microservices, and those microservices talk to other 5 microservices to get your information. I prefer the way that a microservice, if something of interest to other microservices happens, it publishes an event that the other services can consume and make their decision based on it. And also, when doing event sourcing, it gives you the advantage that you have a history of all the state changes, which allows you to do many different things, but we will talk about event sourcing in the next story. So, the event sourcing and data pump story. When looking at this picture, you see a lot of classifieds. I haven't found a picture where there were actually changes of vehicles in the highway. Actually, when you're doing event sourcing, you don't put the whole classified out there, for example, when classified has changed, but only the changes. But in the end, we have the data highway that runs in one way. And one of the decisions when talking about integrating the data center and AWS, because we are migrating, so both systems are running, we decided that we don't want to have calls from AWS to our data center, especially not in the query request response cycle. So if an incoming request hits AWS, it's not allowed to actually make a call back into the data center. This would be a mess. It would couple us to the data center. It would introduce latency. So we decided that if a service in the cloud wants to act on data that's not yet in the cloud, because we are starting building those services, so most of the data is still in the data center, so we decided to push the data that's needed up into the cloud. And event sourcing gives you then also, if you publish events into the cloud, also the possibility to replay the history of all events. A question in between, who knows something about event sourcing, is totally familiar what I'm talking about? And who thinks this is a new idea you haven't not heard before? Okay, glad. Oh!
I do have a question.
Ah, yeah, then go ahead.
So the AWS latency, is it Frankfurt and Munich, or what is the...
Currently we are in Ireland, mainly due to the fact that when we started, Frankfurt was just freshly started, and not all services were available in Frankfurt. And the services that we have user-facing currently are not that important concerning latency, but we are thinking about moving to Frankfurt. Yeah.
So what do you expect the latency to be, roughly?
So I would like to ask guys, but it's it's not very much more than from our data center. So it's in the 100 milliseconds, and then I wouldn't go into detail, but when using AWS, you typically would put CloudFront in front of your EC2 instances and your load balancer, and then you have a different CloudFront point of presence across Europe, because Autoscout is not only operating in Germany but all over Europe. So then this would give you the benefit of latency, because actually the connection from the browser goes to the CloudFront POP and only then back to the data to AWS. Okay. So, and when thinking about this data pump, we had an evolution.
Yes. And so we mentioned before, the first service we spun off another service was the classified service. Just to recap, if you want to show watch lists are classified, I'm interested in, so just earmark them, put them onto my favorites list if you like. And then I can look at the watch list, which lists are these 5 are the ones you have put on your favorite list. Want to see 5 pictures, 5 descriptions, and so forth. So we needed to get some classified data from the data center into the cloud. And we decided to use events for that. And we had some mechanism available in the data center, which is doing a similar task. And so we thought about what do we use on the AWS side. And this is the authentic whiteboard, which we used for a week or two, and which kind of describes all the decisions. And the interesting parts are the crosses. They represent our learnings. So we started using SQS and S3 as a candidate architecture or as candidate services, if you like. So we say, surely we need some queuing in there. We're putting some stuff into one end at AWS, and it pops out at the other end. And the idea behind a service based on event sourcing is many clients, many consumers could register to that service and retrieve the events they're interested in, or events may even be pushed to those consumers. So we didn't know at the time yet what to do. And then the consumer has got all the events and say, now I can do whatever I like. I can replay the history, I can understand the full history, but in our case I want to build a projection from these events which represents the current state. So I just replay, this classified has been created, the color has changed, something has been added to the description, and so forth, until we reach the current state, and this is what we display in the particular case of the watch list. So SQS, throw in some queuing, where events could be pulled from consumers, and use S3 as kind of permanent storage for events, and yeah, we got quite happy with that. And then came along an AWS consultant from professional service and said, have you ever thought about using kinesis? We said, no, we have not, but actually that sounds like a pretty good idea. So we switched horses and pondered using kinesis in combination with S3. So kinesis is a streaming service. You can stream events onto the service, and they sit there for, it used to be up to 24 hours. I think these days it's a bit longer.
I believe it's still 24 hours, but it might change.
And then as a Kinesis client, you can register and kind of pull those events, and it gives you access to a backlog or history of 24 hours. And once these 24 hours are exceeded, we would drop the events and put them into S3, so we could still access them. And we played around with Kinesis. And we found that at this stage we were still happy with Kinesis. And then we started looking at S3 and said, well, actually it's a bit like a file system. So it's got a RESTful API, this is nice, but it's not exactly trivial to query it. So we thought it would be nice to have some storage medium which can actually be queried. Then we thought about, why not use DynamoDB? So we had a stack of events come in via Kinesis, they may be pulled off Kinesis by consumers, but they all go into DynamoDB and then can be retrieved from there. And then we had a deeper look at the Kinesis API, and there are different models how you can retrieve data and different layers of abstraction. You've got the kind of core, hardcore API if you like, and then you've got some convenient stuff and Java API even further above, and some of the features of Kinesis kind of get lost in this abstraction stack. And then we said, this one we were particularly interested in, it's no longer available, so back to SQS in combination with DynamoDB. And then we realized at some point we don't need SQS, because SQS is doing the queuing bit. And we are pulling stuff from the old database in the cache stack, the existing data center. And in particular, in this scenario, we are using a table which effectively implements a queue. So we realized we don't need two queues, so cut out SQS. But then security came along and said, now hang on, are you mad? Are you planning to expose your database to the public? Surely it must be protected and hidden behind a proxy service. Oh yeah. So we want to do that. And you see the proxy up there in the DMZ subnet, which lasted for about a day. Because next morning, when we kind of sobered, we realized, hang on, there is no such thing as your DynamoDB. It's not like Oracle or MySQL where you install your instance on some hardware or on a virtual machine, but it's a global service. You cannot hide it. So off went the proxy, and we just ended up with DynamoDB as our event store. And we're going to look at that at a later stage. What does it mean to use DynamoDB? But before we do so, Christian is going to show us the flow.
Yes, and one addition before showing you the flow, this evolution happened over days, not months, not weeks, and we actually were able to try out Kinesis S3, DynamoDB, spin up new Kinesis streams, tear them down, work with them. This was a refreshing enlightenment for the previous data center times. So we as developers had, using AWS, very fast feedback cycles. In the data center times, when you wanted to have, I want a new this and that in service, there was some evaluation, you need to talk with guys, then sometimes later maybe you get your instances, you get your stuff installed, and this, an evaluation of this things would have taken weeks or months, and we were able to do this in quite a short of time. A lot of stuff happened on the whiteboard, as you have seen, but also actually going to the AWS console, trying out APIs, SDK. So this was a very nice experience for us.
That's good. It's a very good point you mentioned there. And just to give one more reference point, in the previous project, I think we were using an enterprise bus of some sort, which was installed in a data center, and we had different environments for development and test and production. And I think it took 3 months not to get the data bus from all environments. Kind of when they told us it's done, it was, you can't have it in dev, by the way, you have to share the bus on the test environment. And this is literally when the first step where I want to use the queue. 5 minutes, you start writing your test against a queue, you spin it up, and there's your queue. So this is I think it's about a week, it's fair to say. Definitely no more than 2 weeks for this whole journey.
Okay, so what we ended up with is roughly like that. So on the left-hand side we have our data center, and there we have the famous Oracle Autoscal 24 cluster. And as we decided, we want to push data into AWS. So this data pump in here, this is something that's also running within our data center, and it has the credentials to actually access the global DynamoDB, which is then only an outgoing HTTPS call from our data center, and pushes the changes to all our classifieds that are happening back in our data center. So when somebody is placing an ad, or when someone is activating or deactivating one of those classifieds, one further event is pushed into this DynamoDB table that's sitting in AWS. And when doing, for example, classified details, this is the service that's now being built that is responsible if you have found your classified and you actually are on the detail page and see all the details and the pictures on there. This is currently, and this is the flexibility in there, it's actually pulling the stuff he needs out of the event store. So it does not get pushed, its data. This might be at a later stage. But the second service we are currently building, the search, for searching, you can't access, it's not a good idea to access individual classifieds, you need to have them all in some search index. So there is the cloud search we are using, and to actually get all those classifieds in there, we push the changes as they come into the DynamoDB further via a classified index pump. Those orange pieces, if you're not familiar with AWS, simply means these are EC2 instances. So there's actually software running on it, and pushes it further into the cloud search index, and this is then being able to be queried from the classified list. So what you can see is we have two ways of access this event store. When you reason about event sourcing, the push model is actually the thing where people are talking about, but as we are using a queryable database, we have the flexibility to actually go in there and query stuff. But don't go home and think DynamoDB is queryable in any way or shape or form. Relational databases are queryable. We get to this maybe later.
And also, so the classified details, someone asked about performance before and latency, actually. And so when we started thinking this way, the idea was, well, if I have something like classified details or the watch list, they would want to cache the projections. So we kind of keep processing all the events and create our projections, and if and when we need them, we have them ready to go. What we found, this is not necessary in this particular case. So right now, something like classified details is just fetching the events on demand and projecting them, and then rendering the page containing the snapshot, and this is fast enough.
Yes. And many within our teams, and maybe you also, have headaches with this picture. And particularly around this part, previously I told you we have swim lanes, and they are still coupled to the integration database, which is this cluster here in the backend. So is this another integration database that's sitting in there? And you could reason like that about it. It's a database where many services are integrating with. Currently, we have only this details and list. Actually, watch list is not on this picture. It's also one of those consumers that is interested in this classified. And for example, analytics who want to have the price trends over classifieds and other services are in the future interested in those things. So many services are integrating via this table. Are we back at the integration database? I hope not. When we have a closer look at what the service boundaries are actually look like. And we have, this is what I would call a classified service. Actually not the Oracle database itself, but all the stuff behind that that's responsible for publishing classifieds. And the public-facing contract of this service is then the DynamoDB table. You might have heard that a lot of companies integrate the microservices via atom fields, which is the concept that you have a history and current, up to the current state of all your events to be consumed by other services. And we believe that you can use a DynamoDB table for the same purposes, and you don't need to build actually a REST API around it or create atom fields. So we envision that this DynamoDB is a public-facing contract. You have only one that is allowed to write into it, which is the owning service of this public-facing contract. And all the other services are just consuming those events. So we believe that this is not coming back of the integration database. And as I already said, we anticipate more of those. And having a history of all classified events, and if we later have a history of all watchlist events, and we have a history of all those other events, enables us to do things we had on our strategic goal slide. This is the starting of a data lake where every data that is available in your company is there for you to use. So,
right, so it is the DynamoDB is the new item feed. That's our kind of thinking of it, about it. And as Christian mentioned, kind of the excuses around that, kind of say, well, if just one party writing, many parties reading. We've got other excuses, which are like, oh, well, one of the macro architecture is we use AWS. So we don't hesitate to kind of expose DynamoDB as a service. We've got a fairly well-defined contract, but still we have still debates within the teams whether this is the right thing to do. It may turn out that we end up putting some wrapper around DynamoDB. Kind of one example where we are exposing details of DynamoDB is when we started using DynamoDB the first time. AWS just kind of announced, oh, you can also store JSON documents in DynamoDB. And we got very excited. And we thought about MongoDB, and it's going to be like that. And we started putting documents in there. So effectively using one key value pair, where the key says, this is my data, and the value is, this is all the JSON, plus the keys which you need each for the indexes. And then we found out, no, hang on, this cannot be queried, so you cannot easily reach into this one. And so further generations or following implementations using DynamoDB, now we are using it as a key value store, as it is kind of originally intended to be used. And when you change this and integrate via DynamoDB, you've got a breaking change, because all of a sudden the service is delivering a different representation, because what you get when you query DynamoDB are DynamoDB items as a type. And they're putting a thin layer around that, which exposes a JSON representation, helps hiding away those. So we've got a little bit of leaky abstraction here, so technology still leaks out. But we give it a try as we go, and we learn as we go.
And another interesting thing, when we're talking about one of our teams, in the search team, when we're scanning through the whole DynamoDB to build up the index in the cloud search service, this might be a very expensive operation. Some people say, are you stupid? In 1 year we have millions of events in there. It will take days and it will cost us a fortune to actually go through the history of all those events, like event sourcing as a principle tells you to do when you start a new projection. And this is the beauty of not only, sometimes it's just a beauty, but sometimes it's also difficult because you have to make different design decisions. But for AWS, it's possible to actually calculate the price. We made a back of the napkin, but actually it was Excel, but please take care of those bottles. We made a back of the napkin calculation, what it would actually cost us to store a history of all changes to classifieds over 1 year. And we have about 2 million classifieds in our at Autoscout, more than 2 million, and those are changed quite often. And the numbers we came with was in about a year, this will cost us $430 US per month. So I'm not afraid of this anymore. And the second calculation we did is assuming we scan through all those events from 1 year in 2.5 hours, which hopefully the cloud search can cope with. This increasing the throughput of DynamoDB to be that fast and go through all those events, millions of events, in 2.5 hours would cost us $4. So no worries. This thing is actually, in our case, seems to be a cheap solution. And then this has to be in there. Please, if you think about doing event sourcing or doing CQS, ask this guy or read up the stuff he's doing. He's Greg Young, and he's the father or the brainchild behind a lot of those things, and it will help you if you're going down. So the next thing is the watchlist evolution. This is on my... Yes, I'm on this. Okay. Now, as you have seen in the... when we talked about the evolution, how we came up with DynamoDB as an event store and pushing the data, one of the things we feel is important to us is also having an evolutionary architecture. So you won't get it right the first time, so don't over-engineer, just do what's needed right now and then enhance on that. And with watchlist, we had a similar evolution. As Wolf already mentioned, DynamoDB can be used as a JSON document store. The Java SDK allows you to actually put JSON objects into DynamoDB. When you look behind the covers, you will notice that this is not truly the case. It's just mapping to DynamoDB data structures, but nevertheless, it works. And this was about 1 or 2 weeks into the project, and we wanted to save a watchlist. So we invested 1.5 days and were able to actually persist a watchlist, which is more or less a watchlist of one of our users, which contains a list of classified IDs. It's not an interesting data structure, it's a simple representable as a simple JSON document, and we persisted it and went on to tackle other problems. There were still a lot of open questions we had to solve, and left it at that. And the team also decided to do user journey tests. So there was an automated test that every 5 minutes went through the watch list from the outside, added another classified to the watch list, and verified that this item was added to the watch list. And did this every 5 minutes. And everything was fine, up until the team realized the watch list user journey test has problems, and later on they investigated and found out that they had latency spikes visible to the user. So what happened? This is something you have to learn when working with those cloud things. They behave differently. And DynamoDB has, you need to configure your throughput, and you're paying for your throughput. And this synthetic user journey test was adding classified to the same watchlist ID. So this watchlist document got bigger and bigger, and writing it got more expensive, and reading it was also expensive. And additionally, to have some concurrency in there, they implemented optimistic locking. But the user journey test was fast, so he triggered the optimistic locking, which meant when writing from the same user journey test and triggered 2 of those writes, he had to reread it and write it again. And the result of this thing was that actually real users were not able to access the watchlist anymore, because the user journey test was for a short period of time reading and writing a lot of stuff in the DynamoDB, and it exceeded the capacity of the DynamoDB, the provision capacity, so not the real capacity, but the capacity you're paying for. And the reaction DynamoDB that has is just throttles requests, and those throttles requests lead to latency spikes for the real user. And in the end, the team realized, oh, maybe DynamoDB is not good for a document store. So you need to think about when going cloud native about those managed services, how they fit your purpose. And another thing happened to the watchlist team. When thinking about what actually happens in a watchlist, you as a user can add and remove items from the watchlist, and you can get a list of items on the watchlist. So this is a rather simple API, and the current implementation they were integrating with was using local storage. So they needed to adapt to this. And they found out, actually, it's easier for us to not have a add, remove, list API, but to have more of a sync API. This gave them the advantage to have a sane migration, and also gave them offline capabilities. So the mantra offline first was rediscovered. But that led them to the experience when doing synchronization between local storage and the watch list that's stored in DynamoDB, that they're actually not talking anymore about adding and removing. They're talking more about changing things. And when talking about changing things and in discussions, they realized, actually there are events happening. And so they evolved and thought about things that not only from the experience with the latency spikes and the costs involved, but also from an API design standpoint, events would make more sense for them, and they decided to change their data model and their API to actually have events traveling, or change events traveling between the API and also persisted in that way. And when you think about how DynamoDB, how the cost model from DynamoDB is, there's the ratio from read to write is about 1 to 40. So you pay 40 times as much for writing the same amount as reading. And when you go to event sourcing, you're only writing the changes and reading lots of events back. So this is a clear case where event sourcing is actually a cost optimization. And as you can see, the numbers went from $500 to $20. It's not that much, but also this gives them more headroom for the latency. And what could be learned from that? One, still, when an evolutionary architecture makes sense because you need to learn along the way. You can't think everything up front, especially when dealing with new technology and new services you don't know ahead. And they just stick with their document store as long as it made sense for them. And then they were actually brave enough. It took them quite some time to be that brave, a lot of discussions. But then they did the right thing, and it was a pain for them to actually change the API. They had already integrations in place. The previous API, and discussions going back and forth, but in the end, on their path in the evolution, I believe they did the right thing and learned a lot about those cloud services. The next journey.
So, another story. So, we're not just building watch lists all day and classified services, but this is an example for a new product on the kind of shiny new cut where we started building a pricing service, or price estimation service to be precise, where you can estimate the price of a vehicle you're interested in selling and say, well, what would be a good asking price, and the service can be arranged. So the idea behind that is we have shed loads of historic data, and we can run mathematical models on this data, and if you give us some information like this is a make, this is a model, this is the age, mileage, and here are some extras and so forth, we then can give you a price range and say, well, it's not unreasonable to ask for, say, between 8 grand and 10 grand, and so forth. So we built this one, and we also had a kind of a learning curve along the lines of evolving architecture. So the technical elements included there are, you've got an R backend. R is a kind of statistical language where you can kind of express mathematical models and crunch numbers. On top, we've got our Scala Play application. So first we thought, well, surely we need some R backend to be run in the cloud and have a web server sitting on top of that, which is just talking to the R backend. And then we found that there is a tool, let's call it a tool called H2O, which is pretty close to R. It's also doing statistical magic. And we found there is a way to generate H2O artifacts from R artifacts. And you can generate Java code, and you can kind of compile it and put it into libraries and use it from the plain Scala world. So we said, that's brilliant, we put all into one layer. So we no longer have kind of two layers there, but we've got a single play application. And this also contains the pricing models and all the kind of processing and front-end parts to kind of represent that. And then we kind of started using that and developing that. And then we came to a point where we decided it's time to split and let's have a play backend and a play web server again. And the lessons we learned were we had very long feedback cycles from building the middle one, the single play application. And some of the reason was kind of our own fault, because when we think about this pricing application, we've got three ingredients in there. We've got the mathematical models, which sit around as jar files, which are versioned, and use S3 as a repository. So some element in our deployment build pipelines, creating those models and putting them on S3. Then we've got the actual application, which is kind of responding to user requests and giving us the web form and so forth, and which needs to load these models. And then we've got some lookup data or master data, taxonomies and lists of make and models and the like. And they also sit in S3 in a different bucket. And when it comes to deployment, we said, well, we like to kind of normalize and keep things separate. So these three sets of artifacts need to be combined up on deployment. And then we spin up the service, and then we load all the mathematical models into memory, and then we run some smoke tests, and then it's 20 minutes later. So it's taking very long to do so. Also, it turned out to be quite difficult to debug this part of the process. If you are familiar with AWS EC2 nodes, when you spin them up and you describe what they're supposed to do, and if you configure them using CloudFormation, there is an element in there that's called user data, which is effectively, you can imagine like a shell script where you put in a series of commands, and these are executed when the EC2 node boots up. And everything I just described, all the orchestration, get things over here, check they're complete, get things from there, combine them, spin them up, run the smoke test, all goes into the user data section. And we fell into a trap where we said, well, this user data section is becoming a bit cumbersome. Why not use a shell script? Pull it out and just put a call to the shell script into the user data section, which at first glance works nicely, but user data is not easy, not trivial to debug. So you spin up your service, things go wrong, you start wondering what may have gone wrong, oh, let's look into the log. So you go into the web console of AWS, and there you can retrieve the logging, the log from the user data being executed. And on the web console, it stops at some point. It says, I don't tell you the rest. And then you need to SSH onto the machine, something we would ideally want to avoid, so you wouldn't want to use SSH at all. And then you need to find these kind of CF-init, whatever, log files and look in there. It can all be done. But once we introduced the shell script, we felt free to make it very elaborate and kind of very lengthy. So a lesson learned from here was keep those deployment steps really, really simple and really easy. And the next generation is going to be create those, whenever we load pricing models, kind of pre-package them. So that it's that easy to fetch a single artifact from S3 and spin it up. And have all the tests and all the packaging which depend on the tests that depend on the packaging run beforehand. And also frequency of change is quite different. The mathematical models change, don't know, maybe a few times a year, after kind of experimenting is over and which mathematical models give us the best results. And the lookup data also changes a few times a year, but the actual application changes a few times a day. So we coupled our feedback cycle, which we want to run a few times a day, to something that changes a few times a year. So the lesson learned here was kind of separate those things and give them their own feedback cycle and optimize deployment.
It also goes back to the thing that we strive to not start with the small service, we start with a bigger one, and and separate later when needed. So this is a good example.
Yeah, this is where kind of our colleague Eric reminded us every now and then it's called microservices, not nanoservices. When we have about it, let's cut it even smaller. Let's have more of those. Right, so we are reaching the second stage of the third part of our presentation, and it's 8:20. What I would like to suggest, we take a very brief break so you can refresh and grab some beer, possibly some pizza, and in 5 minutes' time we are all back on our seats, apart from the two of us, and we continue the journey.
Yes, good signal.
So, welcome back to part 2. Actually, we are 2/3 through, so there's hope that we're going to see light of day eventually. And in this part of our talk, we're going to look at kind of sharing things, and we're looking at infrastructure in particular. So, when we build the new services, we have plenty of infrastructure underneath, and we thought about some principles. And the first principle is very bold: share nothing. So services should be completely independent and shouldn't share anything. And then we stepped back and said, well, there may be reasons to share things, and so the second principle is kind of availability over shared nothing. So we want the services to be available. And if anything needs to be done that violates this shared nothing, but is relevant to availability wins. So it's beating shared nothing. And the example we're going to look at very soon is about logging services, where you've got a common logging infrastructure, and the reasoning behind that is if things go wrong, availability is less than we would like it to be. It needs to be easy to figure out what's going on, and we don't want services to use different approaches to logging, and I need to kind of crunch many different formats, but I want to have a single place to go and understand what's going on. The next layer is what we call convenience offerings, where we share things that may be used by multiple services, but it's not mandatory. And the example we have here is our CD pipeline. So we started using Go CD, build pipelines and build some infrastructure, kind of Go server and Go agents and different kinds of agents, special agents that can do R and so forth. And then some teams said, well, we would rather like to use something different. And then we say, we don't care. So we've got this built infrastructure, but if you like to use something different, please feel free to do so. You may join forces with another team, or you may build it on your own. It's up to you. And the rule of the game is whatever we share shouldn't have any side effects. And one example we bumped into is we use dashing to create dashboards, and then multiple services shared the same dashing instance running, and I think there was a week or a few days where two teams kind of were using the same name for something without realizing, and were kind of overruling each other metrics, and all of a sudden they had spikes on their dashboard, say, oh, what's going on? Nothing. And then spikes went away and then popped up again, and that was a very nice example for having a side effect. And also when building these shared infrastructures, so we like to have fast local decisions over committees, and we are going to look at that in more detail later as well, where we describe what kind of committees are we actually using in our team setup. So let's think a little bit more about shared nothing. And one of the key questions we faced in very early stages of Tatsu is kind of how many environments do we want to have? And there were roughly two schools of thinking. And one is where I've got these services, I've got the service I'm building myself, I've got services I depend on, and hang on, with AWS it's that easy to spin up a virtual private cloud. So each team, if not each developer, could easily, at the push of a button, spin up their own VPC, deploy stuff there, integrate things. So every team could have their own shadow environment where they integrate at leisure with other services. And we felt this is going to get out of hands. Kind of many of these combinations, it's a combinatoric explosion. And can we get away from that? Can we find a different way of testing these services? And the setup we agreed on is we just have two environments. One is dev, the other one is prod. And then we sprinkle a little bit of be bold on top of that, and we say, well, actually we integrate on prod. We don't integrate on dev. So we just give it a try, if you like. But we've got some measures in place which help us going belly up, or being stupid, as you put it. So when service A depends on service B, we like to use consumer-driven contracts, where service A expresses its expectation on what service B is providing. So let's say service B is providing the classified events, the sample we've seen so far. And different services need different parts of this classified. And so a given service would say, well, my expectation is that I get the number of doors and the mileage and the kind of mixed consumption out of your service. And then the team, using the dependency, is building a fake service, which is fulfilling exactly that contract. And we run the consumer-driven contracts against the fake and against the real thing, as part of the build pipeline of the real thing. And thus, we kind of, it's an interaction, if you like. And so, on dev, the service is using its own fake, but the contracts assure that things are in sync, so that the service on prod is behaving just the same as the fake one did. And so we kind of we reduce spinning up our own instances to kind of wild experimentation when we are trying completely new things, and we say, we want to isolate that one. But it is effectively these two environments we are using. Quite a debate was stirred by the use over reuse. It is one of the principles. So when we kind of go back to the slide, which we're going to do, because we need to start again, where we had all the principles. One learning is that some of these, as I mentioned before, differ from what we have been doing in our professional lives before, and we experienced this as a particular one over the last couple of months. So bringing up new teams, and a team member comes in and says, now hang on, I want to reuse things. It's a good thing to reuse. And from Tatsu we say, no, it is shared nothing. So reuse is a bad thing. And then this is a learning curve. And then we say, well, actually you may be allowed to reuse things, but use them first. And reuse only after hardening, after you have learned that whatever you build is working and is worth sharing. And we've got different ways to share. And the initial stage is just copy and paste. And again, people say, oh, this is horrible. How could you do this? Copy and paste code. It's awful. I've never done this in my life. I would lose my job if I ever mentioned doing so.
Besides copying code from Stack Overflow.
Yes, this is okay. Nobody knows. So you can always put up the anonymous window in the browser and say, nobody would notice. So, but then we're talking about microservices, and they are small. And one aspect is they're easy to replace. And we've got a couple of examples where we copy and paste stuff. And if you look at it, it is the order of magnitude of 5 to 10 classes, plus the corresponding test classes. So it's really a small code base. And the code base then tends to kind of develop into different ways. So it's okay to be inspired and copy and paste, and then you build the stuff you really need. And if things go wrong, we're talking about 5 classes. We're not talking about copy and pasting a huge chunk, which would kind of lock us in horrible technical debt and so forth. The second stage is if then we find, well, this copy and pasting, we identify areas which are of particular interest to other teams. And they don't change very much, and say one team builds the golden implementation of the thing. Then the next stage would be to make it open source software. And this comes in 2 levels. So it could be internal open source, where we say, well, we put it there, and you can pull it and use it if you like, or it could be proper open source, where kind of the public decides whether it's a good thing to do. And so in my team we had a discussion, okay, I really want to share this. Let me share this. And I said, no, We share nothing. And then, okay, I make it open source. I said, well, we need to talk to your product manager, or your product owner, and ask him whether the product owner would rather have us spend time on building the service or spend time on creating open source. And then it was, oh no, it just takes an hour. But it doesn't just take an hour. So it's really about prioritizing. And the agreement was kind of go out into the wide world and find one team who would use the open source project, the internal open source. And then we do it. But unless you find someone, we don't do it at this point in time. And then kind of the third stage, and that's probably the evil stage, I would suggest, kind of have a library. And this is, a few years ago, I believed in sharing libraries, and I was on a project where independent teams built what was called kind of verticals, like large version of microservices. So we didn't know the name microservices at the time. And the domain was about kind of e-commerce, and you had product catalogs, and you had prices. And prices have a currency. And to me it felt surely all prices must have currencies. And wouldn't it be great to have a library representing the prices, and everybody used this library? But it is slowing us down. Because if you start with a library, initially everybody agrees this is a good thing to do. And then you've got kind of competing requests like, I want to go left, no, I want to go right, I'm right, no, I'm left, no, I'm right. And it's just slowing us down. It's not worth, because it's too small to do this.
Okay, so one thing we actually do share, this is a beauty, and it violates one of the principles I told you before, the evolutionary architecture. This is, we fell into our own trap. This is not an evolution. We did the big thing. We believe still that it's somehow the right thing, but it's our unified log processing. So what's the beast? We have services. They want to notify the outside world that something happened, which we call something like an application event. A price was requested, a price estimation example, or a watch list item was added, a watch list was requested, all those application events, which you could write into a log file. We don't like log files. We believe log files are a legacy thing. So we publish JSON events, and we have an event publisher running in our services, and they are published into AWS Kinesis. And as Wolf already told, Kinesis is a streaming service. It's, for those familiar with Kafka, it's the same thing almost, but managed by AWS. And we publish those events into Kinesis, and then we have a collector who, in the current way or shape, puts it into Elasticsearch to be able to be searched via Kibana. So this is the part that felt important to us, very important, because this is how we want to gain insight what actually is happening. So on top of this, you could do queries: how many watch lists were requested, how many prices were estimated, and stuff like that, without crunching through ASCII-based log files. But still, there are systems outside of our controls. So system logs, application logged by the surrounding framework, or web services that don't publish events like we do. So we also need to collect those system logs. There's some fluentd in there, and those go also through Kinesis into Elasticsearch. And then we added collectd for metrics, because you need to know the numbers of CPU usage, free hard disk, and stuff like that. Those go into the system metric streams, and this was the first iteration, go into AWS CloudWatch or InfluxDB or anything else. We don't know yet, but they need to go somewhere. And this is particular for AWS. They have managed load balancers for us, called Elastic Load Balancer. They also emit logs, and those logs are written to S3. And you collect them off S3 and also put them into Kinesis to have a consistent view of all the things that are happening through our services, and have this is something I would call the heartbeat of the platform. So this is one of the core ideas of unified log processing. We have a single point for everything that happens in your system that could be of interest for a diagnosis, for monitoring, and stuff like that. A single point, and put it in there, and then have multiple consumers on there. Currently, we only have Elasticsearch with Kibana sitting in there, but additional consumers could be done. What we like about this solution is that it's easy for a new microservice to participate in this logging infrastructure. So when I build a new service, most of the stuff is already done in the base AMI, so all the plumbing is in place to pull off the system logs. We have one of those copy and paste things where we struggled hard not to make a library out of it, because it's one class implementation and it's one class for tests. It's our event publisher, and now we have 4 services. They have 4 different implementations which have one origin, and we are quite happy with it. And these are publishing events into event streams, and the rest, there's some configuration here. But when those events appear in Kinesis, then by convention all those collectors will pick them up and put them into Elasticsearch. We also plan, and this is more in the realms of building the data lake, also plan to put them into S3 for long-term storage, because you can't keep them in Elasticsearch forever. So in the end, it will be possible for us to have everything stored in S3 and do correlations and stuff on top of it. So this is something we liked to have, and we didn't evolve it. We threw it out there. So this is a little bit of a problem. So what happened in there is that not only did we do big things, we also did things we anticipated that we might use later, which is actually a bad thing, but you need to have all those JVM metrics, because we always have those JVM metrics when we do JVM. Yeah, I'm a .NET developer previously, so we didn't have any metrics from our .NET runtime, and it managed quite well. Actually, at the point in time where we built this pipeline for the JVM metrics via collectd and chainx plugins and coda hail and everything that was buzzworthy, we don't like it to SSH into the box. At that point in time we must, because we had a problem there and we are building our logging infrastructure over there. By the way, building logging and monitoring infrastructure is a new thing. You need to know that. About every major company is building one of those. We're also thinking about making open source out of this. So no. Maybe I'm not kidding, but besides. So, I lost my train of thought by choking. The JVM metrics, and we now have implemented pulling off those metrics, putting it in some service managed influx DB, and only one person knows the credential to the service, and nobody has ever asked for it. So we are not looking into it, but we have built it. This is yes. So we made a mistake, we learned out of that, and there are additional things we did which were not needed at that point in time, which is a little bit of over-engineering. But nevertheless, now it's there, so nevertheless. Another thing that's important for us is that those application logs I already mentioned, these are the important things for us. The ALB logs are also important for latency stuff, but actually we want, as application developer, and you build it, you run it teams, we want to decide what things we want to know about our application and express them as meaningful data structures and consume them with tools that can work on those data structures without going through log files and log parsing afterwards and spending all our money on Splunk and stuff like that. Another problem we had with our logging and monitoring infrastructure is that at some point in time we found out There were question marks around CloudWatch. The CloudWatch might be expensive if we put all our metrics in there. And then we looked into maybe we could use this tool, so we could use InfluxDB, or we could use I'm probably mixing up logging and monitoring tools because there are so many names. We might use Libra tool, Loggly I have on my list, Splunk, Radar, and we spiked about half of the space of things. And so in this realm, you're spoiled by the choice, and you need to make proper decisions, not to waste too much time on things you might not actually need. Nevertheless, having everything in one place, I still believe is a good thing to have.
So we've covered all the technical bits of our journey through microservice land, and what we've seen so far was the easy part. So now let's talk about the people side of things. And we start by looking at, well, how do we try to kind of build autonomous teams, and what makes teams autonomous? And as you've seen before, we've got the idea of a team owning one or more services, building them, running them. And kind of the only constraints are kind of defined by the macro architecture, like, oh, well, you have to use AWS, sorry, it is like that. And it has to be JVM, but then it can be Scala or a different language. And in the, what we call, as Christian explained before, the micro architecture, the team can decide what to do. So right now we are 4 teams. So we started with 1 team last year, then kind of doubled our size to 2 teams and doubled again to 4 teams. And we are about to spin off 2 more teams at the beginning of July. So we've got a little bit of experience. How does it feel? How does it work building up those teams? So things we experience is, well, do not fall back into old behaviors. Like, oh, we've always done it like this way. We just take it into the new world. The world of microservices and the world of cloud is different, and we've seen a few examples in the past. So do we really need this JVM monitoring over there? Do we really want to share things? And don't underestimate the transition to kind of understand these things. In the first team, it was pretty easy. It was just kind of the first team, and we could do whatever we wanted, and we could have healthy debates and take decisions, and then agree on something. And then came in the second team. It was still okay because not so many teams, but with 4 teams, at this point in time we are seeing 4 teams. They all feel very different. They have different team cultures, and I suppose we underestimated when starting the, I need to count, 3rd generation, which is the 4 teams. We underestimated the time it takes to learn things, and there are 2 reasons behind that, I suppose. So doubling all the time, on average, we've got half the team is new to everything and half the team has been around, and we try to maintain a fair mixture across different dimensions. So we say, well, we want to have a good mixture of kind of veterans who've been on this program for quite a while and the newbies. And we want to have a good mixture of people coming from a dev background and people coming from an ops background. And also AutoScout and ThoughtWorks, we want to have a good mixture there and not have kind of one team just the ThoughtWorkers and the other team all the AutoScouts. So different dimensions. And so having done this for more than 7 months, things we have seen before, like the principles and the ideas, general ideas, and event sourcing is the mother of all hammers, they are natural to us. So we say, how could anyone possibly doubt that this is a good thing to do? And then we become a bit impatient, and then someone new on the team raises their hand and says, well, about this event sourcing thing, I'm not sure I really got it, and why can't I just build my library? And then at some point you grow impatient and say, we've always done it like that for the last 7 months, now just get on and cut some software. And there, we need to remember ourselves that we all learned it, and it took us time to learn it, and we need to give our new teammates the same time to do this, to achieve this. Another lesson we learned is kind of what I like to call the Mandelbrot team. So Mandelbrot is around these kind of fractal images where you see fanciful shaped image, and then you zoom in, and it just looks the same. And the idea here is that in the old world we had developers sitting over there and ops people over there. And if you zoom into the DevOps team, you may find, oh, actually you've got 4 developers sitting on that desk and 2 ops people sitting on the other desk. And they are just developing and they are just doing operations things. So it's really important to rotate. So people have different preferences, come from different backgrounds, but if you would want to have a general, shared base knowledge across all team members, and then questions come up on how to achieve this. And we've got different techniques to achieve this. And one is kind of show and tell. So a pair is working on a story and coming up with a particular nifty solution, and they want to share it with the rest of the team. So we just run spontaneous show and tells, and we might invite other teams as well to do so. And we have the traditional showcases, and we created space for kind of wider discussions, why event sourcing, or we had discussions around the logging infrastructure, and kind of larger groups come together. So very important to share the knowledge. The next one is about pager duty. So without pager we cannot really run it. So we're using Ops Genie as a kind of modern pager. And this is where you find where you start building stuff, and you're doing things on AWS, and people scare you with all the stories, what could go wrong if the account is being hacked. And then you've got the lonesome security guy shouting kind of, this is really, really important, and people just kind of ignore it. And you get all the alerts in there, so, oh, too many instances, oh, what does that mean? Oh, unauthorized login attempt, what do I do about that? And initially, we kind of just ignored it, and there's a temptation to click away those email notifications or text messages. At some point, we got phone calls from Ops Genie machines, kind of reminding us we've got unanswered things, unanswered events happening there. And so it's important for the team to understand why this is really crucial. And you need to start practicing it. So before a service is consumer-facing, put up a rota and put up run books, describe what actually needs to be done. Because we figured out one aspect of the ability to run a team, not looking into these alerts is, oh, we don't know what to do. So we started describing recipes, what to do. If you hit this, kind of go there, do there. And start early. Don't just start on the day you go live or you're consumer facing. We experimented a bit with part-time ops, where people from the ops corner joining the teams were there kind of on a rota. So it was effectively 2 people representing 1 person, if you like, and on the even weeks, kind of person A was in the team, and on the odd weeks, person B was on the team, but that didn't work at all because the loss of context, loss of knowledge, so we stopped that. And not all the T-shapes are the same, so T-shapes are, I've got a broad knowledge, as I mentioned before, but the T goes very deep into one particular aspect, and it's a good practice to respect that, and kind of take into account personal preferences, as long as the team is happy and capable of building and running the service.
So another part of autonomous teams is that we believe that ops, as Wolf already mentioned, should be part of the team. And nevertheless, Spotify knows what's interesting up there.
Okay.
Do you recognize yourself? No.
No, my brother.
No, really.
It's on the left side.
And it looks familiar. Yes. So. So we have a tutor in the guild at Autoscout which is posing for us. I'm glad he's not one of those lying guys. Okay, the infrastructure guild. This is something we believe ops should be part of the team, and we believe that you build it, run it. But there is at least no blueprint out there that fits our needs. So we're a little bit experimenting on this front. So how should this work? How do we share knowledge between ops guys, which used to be in one department and work together all the day, so sharing knowledge was not a problem. The Spotify guild seemed to be a good example how this could work, right? When ops guys are still a part of the team and share their learnings. Also, a lot of the things we try to build are microservices with micro decisions made in the teams. The same should go for infrastructure. But there is nevertheless macro infrastructure and shared infrastructure, as we have seen with the logging example. So we need a way to agree on the things what to do and in which priority and take care that's be done. And nevertheless, we don't try to do work in the infrastructure guild. We try to actually do the work in the teams, and the infrastructure guild is sharing and delegating the things to the team. And another important realization for us is, as Wolf already mentioned, one of the things discussable, but it's, I believe, the right thing to do. We don't want to share things. Therefore, we don't want to have a lot of shared infrastructure. We only want shared infrastructure where we don't have a solution that's fitting a team, but it needs to be a shared solution, security, logging as examples. So the backlog that's maintained within the infrastructure guild should ideally be empty. There shouldn't be something that needs to be done. And this leads to what I believe is the stronger the infrastructure guild gets, or even if you have an infrastructure product team with the sole purpose of building infrastructure products, shared infrastructure, they will do it. You can't stop them. You can't stop institutions from creating their own stories. So if you want to read up the Shirky principle, which explains more in depth what I mean. So we have the success that we embedded in our cross-functional teams, the operations guys, and actually they do like to work that way, and we as a team like to work that way, and most of the infrastructure should be built within the team for the team, and only what's needed should be built in an overarching theme. But the danger lies that from this dotted line, where the home of those guys is a team and they have a guild where they share knowledge, that this becomes the stronger bond goes to the guild, and this then becomes their home. So what's the funny part? Experiences? So this is what we call the risk of the shadow team, that you have a team within the team, as Wolf already mentioned, the Mandelbrot team, ops sitting on this side and dev sitting on that side, and on the outside it looks like a cross-functional team, but in the end they're working on their own stuff. So this is important to us that it does not happen. Why is it important to us? Because if they have the home of the operation guys, the infrastructure guild, and they work together very strongly and don't rotate with each other, the team loses its ability to actually do you build it, you run it. The team must be able to support the services, not the two ops guys within the team are the only one that can run the services, because when they're on holiday, what should the team do? So we don't want this dependency to the guild or to those special guys in there. The team should, despite having different T-shapes, be responsible for their stuff. So the focus slider.
Right, so life is a slider. It's all about kind of taking choices and understanding the trade-offs. And so when we started this program, we had kind of what is our focus? And we found that focus shifts over time, as we can see here. So this timeline represents chunks of this. The first block is kind of 2 months, the second one is about 3 months, and the other stuff is ongoing. And when we started Tatsu, we had many new things to learn. And most of these things were around platform and technology. And we chose the watch list as an easy to understand, easy to implement guinea pig, because there's no complexity in there. So for the first 2 months, kind of 20% of our focus was on the product, the new watch list, and 80% was on the platform. And when we had the first service kind of up and running and learned our first lessons, In the second phase, we move to a kind of a 50-50 model, where we say, okay, 50% of our effort goes into understanding, extending the platform, but 50% go into product. And this is on the timeline when the new price estimation product was entering the scene. And this is about the crucial time of such a program. Because initially, kind of product people say, well, yeah, these IT people, they play around, they've got a new platform, and it's all very exciting, but what does it mean to us? Where do I get my new features? Surely not on this thin layer of product over the first couple of months. So there's a tendency not to take it too serious, if you like, or whether it's not doing much for me, I stick to the cache stack, I stick to the existing systems. And the second phase is where you need to get buy-in from business people. They need to engage. An experience we made is that the two teams at the time, building watch list and price estimation, were suffering from a lack of attendance from product owners. And it may feel nice because you can do fanciful things and you can build, for example, heavy logging infrastructure because you've got all the time to do these things, but it's not achieving the goal, it's not helping towards building new products. So when we realized this is happening, we all started screaming and shouting and said we really need PO attendance in there. And so this is kind of the ideal line, and right now we have got a way stronger product focus with the 4 teams. It's still something to keep an eye on, because there's still a risk that kind of business may not take the new initiative serious. But so the second phase is the takeaway here. Look out for the second phase and get business people, get product owners involved into what you're doing.
So, we've reached the last slide. Continuing with the focus sliders, we, as we already told you, still have what we call the cache stack running. So we have the shiny new cut building stuff in AWS, and we also have the cache stack. And what's important for us in this weighing things is that we don't split in 2 parts. So in order to actually make this apparent in the language, previously we called it the legacy stack. This is a bad thing, because this is the old stuff and we are working on the new stuff. So we are using the word not anymore, we are using the word cache stack, which emphasizes this is only earning the money to actually support this new endeavor. And this makes clear that despite starting a new project, building new stuff, we are still one company and we need to support the same thing. And the same goes for keeping the lights on in the cache stack, which is something easy to ignore, and you have to balance stuff, because the more energy you put on building the new platform, the sooner you might get rid of your cache stack and earn the cash with the new stuff. But in the time between, you also need to maintain the cache stack, so you can't alienate people working there, and you need to also support it, because this must be a stable platform to be attractive to the user. Another thing we need to consider is that when cutting out those vertical slices, we have told you about that when we build microservices out of them, this is not a good time to actually have feature changes on the vertical slice you're cutting out there and rebuilding on the other side. So there will be a point in time where we actually say, now stop it, no more features in this vertical slice, pick the one on the left or right side, but there's a feature freeze. This is in a state of transition, and this allows us to not have double work. The last part is we still need to integrate those new services in the cloud platform with the services running in the cache stack. And the decision you have to make is how good the integration is and how easy this is for the business people to actually work with both sides. The more time you invest in the integration and the easier it is to smoothly integrate all the parts together, the easier it is for the business people to actually work on both sides, but it prolongs the time that you need for the transformation because you're investing in the integration. The harder the cuts are concerning integration, so if you put it just from here to there with no integration, you will be fast than when you have to integrate all the time. So this is also something where those sliders change over time. And this also comes back to time to market, and new features need to be built versus the fast replatforming. And the last thing to mention there is be aware of the N+1 system effect. Wolf had a nice story around that one from previous projects, where you just build a shiny new thing, which becomes the N+1 thing that also does the same. Before it was a shop system in your example, and after you've left the project to start the next project to build the even shinier, and then you have N+1. You also, when cutting out those vertical slices, it is important that you actually remove the code, remove those services, and replace them, so that you're not adding, but you're actually cutting. So this is the difference there.
And what is helping us here is the principle we have been able to maintain so far of the one-way road. So data flows from the cache stack world into AWS, like in the example with the classified service. Because you can start, well, I need this piece of information. Why don't I just call back to the existing service in the cache stack? But then you increase the risk that this is never turned off. Then it becomes the kind of N+1 service, and you still keep the old one running. Following the principle, whatever I need to build it in the new world, helps in turning off things in the new world, in the old world.
So, and I lied to you, I have one more. This is then an example of not only evolutionary architecture, but also of throwing things away. Let's look whether this works out. No! Oh! Damn. I have to click somewhere.
So yes, welcome to Autoscout. I'm just thinking about a particular architecture, how to integrate existing data center with AWS world. So we started thinking about this, uncovered some points and we thought, this may be too complex. Then we found a much easier architecture down here, which is becoming easier by the hour, literally. And we've got a particular way of dealing with complex architectures, which is just erasing. So I like to call this whiteboarding 2.0. And then story behind that, there was a cover on the new whiteboard. We didn't realize it was there, but we complained all the time, why can't we clean this whiteboard?
And after 3 days of going through iterations of whiteboard sessions, we had the realization.
Yeah, we noticed the red sticker, the yellow sticker which says pull here.
Okay, thank you very much.
So we have time for questions. Please raise your hand. I come along with the microphone, and so we don't need to repeat the questions. So we just start here.
Thank you. My understanding is that you're driving a hybrid mode, kind of. You're having your legacy applications still running, and you having a part of your business logic being microservices and running parallel. So where do you stand today in percentage? This will be my first question. And I have still another one, which is maybe a little bit more technical. How do you deal with the configuration management, considering the growing number of microservices?
Okay, so in number of percentages, my guesstimation would be around 5%. So we're not very far. Is it right? I'm looking at 2%. So it's hard to actually come up with a number. Actually, we have one service that is actually user-facing and handling real traffic, and we have a service that's handling traffic that did not exist before, so this was not a transformation, it was new build, the price estimation service, so this doesn't count into that number. And we have two other services that are currently in the stage of being built. To put this into context, we started 6 months ago with one team, then we went 3 or 4 months with 2 teams, and now for about 2 months with another 2 teams. So we are at 4 teams right now, and there was a lot of groundwork getting to you. We changed everything, so we were still at the beginning. So this is not a success story, this is a work in progress story. And the second question was how we actually do configuration management with all those microservices. The one answer is we don't have a lot of microservices yet. The second answer would be actually to avoid a lot of configuration management in the sense of chef puppet stuff like that. We mainly go the route of immutable services, immutable servers, so each deployment actually creates a new instance of the service.
So if I understand this correctly, you have migrated mostly read services over to AWS, and you're abstracting with the DynamoDB data into AWS. What are you going to do when you've migrated all read services over and the write services would come next?
I believe we would think hard about how to proceed. So, in essence, why we picked the read traffic first is Autoscout is what defines us, and what we are mainly talking about is how we are scaling and how we are dealing with all the searches. So this was, from a technical perspective, the risky part. Are we able to serve this with a reasonable amount of money out of AWS? So we want to verify this first. And as might seem, it's also somehow the easier part, because you don't have to deal with all this business logic and actually how you integrate those microservices. The hope is that we can keep, not the current state, but an evolution of what we are now doing with the Atom feed DynamoDB as the public API for those services, and don't need to change the public-facing read part, and then build proper services that are not going through the database, and their contract is then those feeds. But we need to think hard about this. So this is the next phase, and the next meetup talk is lurking there.
Okay. How much effort does it take to roll out a new version of a web service or a microservice? And if it doesn't work, how much effort does it take to roll back to the old version?
Okay. Git push, wait. If it's green, it will be live depending on the cycle time of the different pipelines. So we have this example of price estimation where it took 20 minutes, which is not favorable, but for one stage. But actually, currently we don't have any manual intervention between the code commit and the going live. So no effort. Rolling back depends. If currently we don't have a sophisticated canary release in there, we are mostly relying on CloudFormation, and CloudFormation works for us in a way that we have a smoke test that Wolf already mentioned. When the EC2 instance with the new version comes up, there is a smoke test running, and if this smoke test is green, then the instance we assume is healthy, and then CloudFormation knows this is a healthy instance and will automatically replace previous one, and if it's not healthy, it will automatically roll back the instance. So we don't have any plumbing around this yet, so we are relying on what's working out of the box with AWS, and up until now we didn't have problems with it.
My question is about the idea, the concept of self-containing microservices. I think you, Wolf, you talked about that the but there's a concept or an idea that all the microservices bring their own UI. And in my opinion, there's always something of style or icons you have to share. Can you tell us something about this?
Yes, so the first steps we are taking in this world is kind of one part is the technical bit, how do I integrate parts of UI, and we're using edge side includes, so we run varnish, and kind of different services provide different elements that all make up the page, and we need to have either a master page or a page is requesting stuff from another service, and the varnish is integrating the stuff. And in terms of look and feel, we've got a library of CSS files which are compiled into CSS, and these are the building blocks of our look and feel. So in the service says, oh, I want to use my UI and it should look like this and that. So the service is building its own CSS, but using the components and elements from this library, which then becomes a shared thing.
And I want to add, we specifically decided that way. We are currently in the phase of experimenting with that, but we have specifically decided against one asset pipeline, one centralized asset pipeline, because this would violate the not sharing thing, and it would actually might couple services to each other. So we hope that by doing clever things with edge-side includes, that are also the services themselves can be responsible for their assets and can take their appropriate action. There might be a service that needs to have minimized cached assets because it's one of those public-facing sites with millions of requests per day and highly optimized. And for another example is the price estimation, which is not as much used, and the other team says, I don't want to put effort into all this page speed optimization. This is not my concern. I'm calculating prices and don't get that much visits. So this is something we try to keep within the autonomous teams. Ben?
I have a non-technical question. I guess at the beginning you said one goal is to do cost efficiency, and a little bit later you said another goal is to reduce time to market. Doesn't you think these two goals are in contrast to each other? Okay,
so when talking about cost efficiency, we think in terms of AWS costs, and if real cost, for example, team or redundancy is involved, so the example is if you share stuff, you might be more efficient. This might also be more cost efficient, but it makes you slower because you then have to communicate with different teams. So this is one of the things where we believe time to market is actually more important than reducing the costs. Besides, in the end, we also want cost, and we didn't say cost efficiency, I believe we said cost transparency, hopefully. So the most important thing first is to be aware of the costs, and if then you see this is something where you can be more efficient, then you can optimize later on. And this triggers some design decisions. When using AWS services, at least for us, you have to learn a new way of designing things. You can't just say, I use this and I use that, because it's already there, it's in the data center, it's paid for. You need to make your design decisions along the lines how those services you're actually paying for. And this is meant by cost efficiency, and if in doubt, I'd say rather be fast than save money.
And it was one of the experiences we made is around cost, and Christian mentioned it before. It's easy to do a calculation, how much is this going to cost using service X over service Y provided by AWS. And this is really, that's really excited people on the team, and the AutoScout CTO in particular, when he observed us talking about and thinking in terms of cost. The flip side of the coin is sometimes we experience discussion, kind of, oh, we need to be aware of cost, and when the discussion becomes too nitty-gritty detailed, the image I like to use, well, we've just reached break-even, this discussion has cost more than any possible saving that could come out of this discussion. But it's a great experience to see, to be able to look at these other tools. Let's make a rough calculation. It's going to cost that much. Yeah, that's okay. So you just go ahead. And right now we are talking rather about hundreds of US dollars per month, and not kind of thousands or tens of thousands. Right, but you've got another question here.
Yes. One simple question. Who was involved into the definition of the macro architecture rules, or was it a team, or was it some separate architects, or?
So by separate architecture, I could. This it wasn't me. So some of the macro architecture decisions were taken up front when thinking about what needs to be macro architecture and what not. And there are some things where it's rather easy to reason about. Security in a network perspective, for example, is a clear cut. This can't be left to the discretion of teams. Besides that, we talked about the infrastructure guild. We also have a macro architecture guild, where the tech leads of all the teams meet once a week and talk especially about those topics, which is part of the macro architecture, which is micro architecture, and what macro architecture decisions need to be taken. And we always strive, and this is sometimes a revelation, that things that at first glance look like this must be macro architecture mustn't be. For example, the UI composition mentioned, this could be the UI composition layer sitting on top of all those services and being, for example, a big varnish cluster, but it could also be varnish clusters in front of those services. Part of the decisions need to be shared. UI library designs, these are macro decisions because the user doesn't want to have the impression that each of those services was built by a different team and it looks like a different service, but whether this team decides to do UI composition with this version of varnish and this uses a different version, this doesn't need to be macro.
So you have no macro architect?
No. No.
That's my question.
Yes.
Just have tall architects.
Yes, but we are in the 10 towers, so there is the danger of the architect in the ivory tower. Yes.
Any more questions? I take that as a no, so thank you very much and have some pizza and beer.